All right, so let's continue where we left off. We were doing law of cosines. This is case 3. We have one angle and two sides. We don't have the one opposite to the given angle. So we got to do law of cosine. If we're doing law of cosine, we don't have to worry about multiple triangles, so let's just find the missing parts. Uh, all right, so let's plug it in. So this will be minus, so it's going to be d squared plus c squared minus 2bc, so 2 times b times c, cosine of 46.5. All right, let's find out what it is. Oops. Damn it. Okay, so 2 times b times c, cosine 46.5. All right. Let's round in one decimal place. That should be 13.2. And remember that you cannot find any angles with law of cosines unless you have all three sides. So first find the sides, and we've done that. So we'll use the formulas for angles. So b is equal to cosine inverse. Here's a formula from last time. A squared plus c squared minus b squared over 2ac. I plug everything in. That'll be 13.2 squared plus 18 squared minus b squared over 2 times a times c. See what that is? Cosine inverse. Use the fraction button, make it prettier. It'll be 13.2 squared plus 18 squared minus 10.5 squared over 2 times 13.2 times 18. All right. So we'll round to one decimal, 35.3 degrees. All right, box the ones that we found. Once you have two angles, you're pretty much done, right? C will equal 180 degrees minus A minus B, which is 180 minus 46.5 minus 35.3, whatever that is. That's it. So in the exam, I have you solve the triangle, then right after, I'm going to ask you to find the area of the previous question, so of problem 5. Okay. So most likely right after solving a triangle, I'll ask find the area. Okay. And in order to do so, I recommended the Hero's formula, where the area is equal to the square root of s times s minus a, s minus b, and s minus c. And then find s equal to 1/2 the sum of all the sides. So that'll be 0.5 times 13.2 plus 10.5 plus 18. And that should be 20.85. All right, so let's do the area. Area is equal to 20.85 times 20.85 minus 13.2, 20.85 minus 10.5, 20.85 minus 18. Whatever that is. That will be your area. Should be 68.6. Since they didn't give us any measurements, we'll just call it squared units. So any questions on number 5 or number 6? Did okay?
On the very first part, first like square root, is that 5 s or
There's no, yeah, it's an S.
it's that?
This is a formula, no numbers. Excuse me. Yeah. Right. Good sleep, I guess. You guys cool on 5? No problems here? Okay. Oh, wait a sec. Okay. So no issues on 6, right? Let's do another one, and I'll ask you the same thing. Find the area right after. Solve the triangle. A is, so this is still 8.2. A is not given. B is 88. C is not given. 4.4. B is not given. Little c is 5.2. So by looking at by looking at this, can you tell that it's law of sine or law of cosine? Does everyone see why it's cosine? Let me know. Okay. All right, well, find little b, because you need all three sides to find the angles, right? So use the b formula. Right here. So that will be 4.4 squared plus 5.2 squared minus 2 times 4.4 times 5.2 cosine 88. I think it's 6.7. Just double check me. Excuse me. Okay. So same as last time. As soon as you have all sides, start finding your angles, and you'll be good. Let's do A first. So A is equal to, this is the formula I made for you. Cosine inverse of B squared plus C squared minus A squared over 2BC. Excuse me. So this will be cosine inverse of 6.7 squared plus 5.2 squared minus 4.4 squared. That'll be 2 times B times C. Yeah, that's good. You got to write the answer. You guys get 6.7 for B? Okay. You guys agree with 41 degrees for A? Okay, then we're good. Last part's the easy part, right? All right. So capital C is just simply 180 minus A minus B, which will be 180 minus 41 minus 88, which is 51, right? And that's it. We got all the angles and all the sides. Any questions about any of the steps here? It's like 1, 2, 3, the three steps. Yeah.
It's not really about the steps for so for us, approximately, we'll get points from that, because I understand like approximately because we're rounding everything, something in there, there's like obviously like error code. But sometimes I forget.
I mean, I'm not gonna be a stickler about it, but I mean, you should know if you punch anything into a calculator, it's no longer equal, right? As soon as you start seeing decimals, uh, that's it, right?
Yeah, I don't know.
Yeah, that would be nice so I can find your stuff
Okay.
easily. Try to be as neat as you can. That way I don't miss anything. Okay, so part A, just find the area. Find the area of problem 7, yeah. The same as before. Find your S first, so S is equal to 1/2 the sum of the sides. So that'll equal 1/2 times 4.4 plus 6.7 plus 5.2. Should be 8.15, right? So area will equal S times S minus A times S minus B times S minus C. So that will be 8.15. 8.15 minus 4.4. 8.15 minus 6.7. 8.15 minus 5.2. Should be good. So if these are all in centimeters, you would write centimeter squared, right? Yep. No, but just show your work so I know, okay, you know what you're talking about. It's just that you round it differently. Okay. A2 is not a big deal. Since if I don't tell you what to round to, then that's fine. Just be careful. Don't round too much. These are all in single decimal points, so it makes sense to round to 1 decimal point. I think that would be fair. Be fine. Any other questions on number 8? So we move on to 8.3. So at least I'm thinking about have the exam be solve triangles, find area. The other half will be polar stuff. Okay. I'm gonna skip 8.5 on the exam. So you won't see any material from 8.5, which was the imaginary stuff, the sine I theta, whatever.
Oh, I had a question in terms of, so, over and, there's a question about a conjugate. Went over that.
I believe so, yeah. Conjugates, imaginaries usually come in pairs. You multiply the conjugates.
I was just confused with what that was like you had imaginary, and it was like square root.
Show me after if you want.
I had something else to do. Not sure.
I don't remember honestly. I'd have to look at the notes. Let's see here. Polar coordinates number 9 is just, let's just start by changing the points to polar points. So change the following to polar coordinates. They're going to give us 3, -5. And the restriction they give us is that they want r to be positive, and they want theta to be between 0 and 2 pi. So this is the hint that you should be using radians, but I don't care if you use degrees. So I'm going to use degrees the entire time, and feel free to do so on the exam. I would prefer it. So here we go. So we got x and y. So we should know that r is equal to plus or minus square root theta is equal to tan inverse of y over x. So since they said r must be positive, then use the plus and plug in your x and y. So that will be 3 squared plus -5 squared. That'll be 9 plus 25, which is square root of 34, right? Okay, so there's r. Now find your theta. This will be equal to -5 over 3, which will be -59.04 degrees on your calculator. I think. -5%. So keep in mind, which quadrant is 3, -5 in? Quadrant 4, and so is this one, right? This is also quadrant 4, but they told us they wanted it to be between 0 and 2 pi. They don't want negative angles. So fix it. So this is the same as doing -59 plus 360.
On the exam, are you radians or
Degrees. All right. So we got the r and the theta, so that's it. Yep.
is it possible to use like a higher number? It's like at 360 it's still right.
Well, if it's a negative angle, so remember, tan inverse is going to give you answers or angles in quadrant 1 and quadrant 4. If it appears in 4, then it's going to be negative. So you got to add 360 to fix it. If it turns out that it's not in quadrant 1 or 4, then you'd have to adjust. So you always keep in mind where you're at. So I knew this was 4, so I make sure to adjust to 4. But let's say that the x was negative and y was positive, then that would be quadrant 2. So you would have to adjust this angle to give you the equivalent angle in quadrant 2 by just adding 180. So yeah, always remember where are we? So going to from x and y to r theta, we get this. All right, that's all they wanted. Any questions? Any other questions on number 9? Okay. All right, let's go the other direction. The 5 comma pi changes to rectangular. This is our theta. Right? It's always r comma theta when you're in polar. So remember that x is equal to r cosine and y is equal to r sine. Well, that's really all we need because we have the r and the theta. So x will equal 5 cosine pi, y will equal 5 sine pi. Cosine of pi is -1, right? Sine of pi is a 0. Technically 5 times 0. Anyway, so that gives us of x value -5 and 0. So we can go from 5 comma pi to 5 -5 comma 0. Any questions on number 10? If you were to plot r theta, you can see that pi is over here, right? Going out 5 be 1, 2, 3, 4, 5, so you would be right there doing the polar plot. If you plot it in x and y, you'd see that it's the same spot, right? -5, 0. So these are equivalent points. But technically, the polar grids are like, they have the little circles, right? Going up. I'm not going to draw that, but same spot. Guys, okay on number 10. All right, you guys cool on this page? So I'm thinking like 4 or 5 questions from 8.1, 8.2, 4 to 5 questions from 8.3 and 8.8. Then that'll be it. Okay. Let's do converting equations, polar equations. Let's turn the page. That's cool. All right. Number 11. Still same section, 8.3, right? Yeah. So convert the Cartesian equation to polar. So basically go from x and y to r theta. That's it. So here's the Cartesian equation. Also, same thing as rectangular. So if the book uses Cartesian or rectangular, it's the same thing. It's just one's named after some dude and the other one's more proper name. Okay. Cartesian was the first one who created the grid, X and Y grid. I think the story was he was staring at the ceiling, looking at flies. Yeah, he was looking at flies on the ceiling and he started thinking about X and Y points. So I think that's why it's named after him. He's the first guy who made plots. Yeah, it was probably super bored. Yeah. But anyway, we're changing Cartesian or rectangular to polar. We're going to need these formulas. Okay. We're also going to need, well, no, I think that's it. Okay. So just plug in your x and your y and your other x, you'll be good. Okay. So r cosine plus r sine is equal to 3 times r cosine. So all I did was substitute all your x's and y's. That's it. Now square everything and simplify. This will become r squared cosine squared, r squared sine squared equal to 3r cosine theta. So at this point, you've technically already gotten to polar. So just start simplifying as much as you can. You should see a Pythagorean identity right here. So factor the r squared, and notice this is equal to 1, right? So that becomes 1. Cool. At this point, if you get to this point, it's good enough for me, but you can still keep going. You can divide both sides by r. Make it a little prettier. So you get r equal to 3 cosine theta. I would accept anything right here. That's good enough. But if you miss an identity like that, you will lose some points. You'll have most of them for getting to here, though. That's, that to me shows me you know what you're doing, you just didn't finish. Any questions on 11? All right, let's go the other direction then. Let's go from polar to rectangular. Okay. So here's your polar equation. I just picked a random one from the homework or from the book. I might pick easier ones for your exam. I don't know. We'll see. So I want to go from here to x's and y's. No r's, no thetas, no trig. So what I recommend is multiply both sides by the denominator. That way you cancel the fraction, and then you have the r being multiplied on these pieces, because you know that r sine and r cosine is going to be x and y, right? So that's what we want to try. So right here, multiply by sine theta plus 7 cosine theta on both sides. Oops. So that'll be r sine theta plus 7r cosine equal to 4. That step okay? So at this point you should see that this is y and 7x. And that's pretty much it. Is there any questions on number 12?
Could you simplify even more by putting the x by 7?
You could, I mean, I don't think that'd be more simple, but you could do that. But then you'd have a fraction on the y.
If you divide the 7x by 7.
Because you'd have to do both parts, right? Because if you divide by 7, you have to do it to everything on both sides. So then this would become y over 7. This would be 4 over 7. Which is not wrong, but it's not any prettier. You could solve for y, I guess. I think that'd be the next best thing. So, if you want to. All right, let's move on to the vectors. We'll do one more question, and then we'll stop there. And then Friday we'll just focus on vectors and any questions you might have. So one more problem. You guys cool on this page? Oh, wait a second. Okay. 8.8 is vectors. Find the magnitude oh, hold on. Let's do it in order. Find the position vector. V. Then find its magnitude and direction. Given P1 -1, comma 1, -1. And P2, -4, 5. Okay, so obviously you can't do anything until you find the position vector. So first thing you should do is take the final point minus the initial point, so it'll be -4i minus -1i plus 5j minus -1j. Okay, so that'll be -4i plus 1i plus 5j plus 1j. So this is -3i plus 6j, which is the same, if you prefer, -3i comma 6. All right, so once you have this, you can answer the questions, or the rest of the questions. So this is position vector v. Magnitude of v is equal to the square root of a squared plus b squared. So this will be -3 squared plus 6 squared. That'll be 9 plus 36. 36 plus 9 is 45, right? Which reduces. There's my magnitude. My vector. Or if you prefer, one of these. What's up?
Can you give exact?
Yeah, this is the exact
I know, but like,
approximation. I mean, I prefer the exact, but if you went from here and then gave me a decimal, that's fine. But show something in between, right? Okay. Direction. Direction theta is equal to tan inverse of b over a, which will be, in this case, 6 over -3. That gives me -63.4. So now we got to figure out, okay, what quadrant are we in? What quadrant is this? Yeah, it looks like -3, 6. That would be quadrant 2. Quadrant 2. This angle is quadrant 4, but the actual location of the vector is quadrant 2. So adjust this this here. So add 180 to get to the actual solution. Okay. There's my direction. Any question on number 13? Let me take roll before I forget. Is Emily Ayala here? Jacob, Matthew Danda, Sarah Flores, Gabe, Gabriel Garcia, oh, yeah. Edith Gutierrez, Gracia Hernandez, Valerie Hover, Ali Kareem, Kiana Kennedy, Jacob King, Cassidy Luna, Toby Martinez, Joshua McDaniel, Iala Mitchell, Josephine Mosquera, Clarissa Nunes, here, oh, Jose Ochoa, Manuel Palma, Alexis not here today. Alexis, Sophia Sanchez, Ismael Sarhill, No Sarhill, Manuel Urbina, Sydney Varela, Olivia. All right.